Hey guys, it's IDW and welcome to a brand new series. And it's been a while since I was really doing advanced redstone stuff. I was trying to keep up the learning to fly thing, and I think I might eventually end up bringing that back. But even though I want to expand into non-digital forms of redstone, I think it's about time I got back into digital redstone. And honestly, considering how many of my viewers watch my videos specifically for my redstone content, I thought I might as well do this because it's the next, in some ways, I guess it's the next logical step from my computer function series, but on the other hand, in some ways it's not. Now, I'm going to be explaining exactly what I mean by that later in this video, but for the moment you should just know that coming into this, you do not actually need to know anything about computer functionality. You do not need to have watched my computer function series. That's really just going to be something that's going to be working alongside that. Now, we're going to be talking about that later, but in order to introduce exactly what we're talking about, it's kind of hard to talk about machine code and stuff without actually understanding what it is first. So I'm going to, instead of doing what I usually do and do like my kind of introduction now, I'm actually going to do it more later for you to decide if this is the sort of thing you want to be watching. So without any further ado, let's talk about information in electronics. And again, I'm kind of starting at the very beginning here because you don't necessarily need to know anything about a computer. As a matter of fact, you don't even need to even know how to get to this video in order to understand what I'm going to be explaining. So, let's get into it. So, let's start with a simple analogy here. You're in a room and you have a light switch. Only for some reason you can't, and there's someone else in the room with you, only for some reason you can't talk to them. So you want to send information to you. So what you do is you grab the light switch, and you can flip it on and off. And this will allow you to send information in some form, say Morse code or ACSII, but that's... Morse code's a lot simpler for someone to understand. So this is basically the most basic way that you can send information through electronics, because if you think about it, you have two different states that the light switch can be in, and you're sending that information to the other person one certain amount of time at a time. So, for example, if I was to say every second I was to change the light switch, then I would be sending a different amount of information every light switch. So yeah. Anyways, so with that out of the way, we can go ahead and talk about the next step of this. Because you can send the information twice as fast as you would normally if you were to just add a second light switch in there. So let's say you do have that second light switch in there. Suddenly, you can send, instead of being able to have two pieces of information sent in the amount of time between each time that you send information, you can have four different states that the light can be in. You can have one light off, one light off, one light on, the other light off, the other light on, the first light off, and both lights on. Now, if you think about this, you can keep adding lights until you can send information in a lot bigger chunks, right? And you can just keep scaling it up, right? So if we start getting really big with this, we can really start to assign some big information to this. If you get five different wires, then you can assign every letter of the alphabet to it. You can also assign numbers to it. And the result that you get when you do assign numbers according to this code that we have right here, where 0, 0 equals 0, and 0, 1 equals 1, and 1, 0 equals 2, and 1, 1 equals 3, you get a counting system known as binary. And this is the way that computers actually represent numbers. So you'll have like a whole bunch of wires, and then each one is going to be on or off. So as you keep adding more and more pieces of information, you can have more than just the numbers 0 through 3. If you were to have 3, you could get 0 through 7, because 7 is your highest value. Now, this is actually all that binary is, just being able to use on and off signals to send information like this. And a lot of times, like in movies, you'll hear binary portrayed as this complicated code of ones and zeros which humans can't understand. And in some ways that is true, but honestly, binary is a lot simpler than a lot of people realize. It's literally just this. It's just another way of representing like the number 3. We would say it's 1, 1 instead of 3. So just to clarify that. Anyways, so now let's talk about compiling, which is exactly what I just said, is kind of what you see in movies. Because let's start with the fact that binary systems represent every single kind of information in a computer. Literally everything, like the text in this PowerPoint. It's not text on your screen, it's an image, but in this PowerPoint it's being saved as text. So every single piece of information, including the text, is being saved as a combination of ones and zeros. Each pixel on the screen, it's got numbers that represent the colors in it, and it's also got a number that represents the hardness, and all those numbers are represented by binary. So yeah, binary is kind of important to computers. But we are specifically taught to handle the decimal counting system and decimal systems in general. For example, just look at this number right here, 11101001. It's a lot easier to just say 233 and you actually know what that is, right? But this just demonstrates that, of course, if we were to be taught binary when we are learning, then we could easily use it. But we use base 10 instead. Now, another important piece of information that computers are going to understand and take information in is if you want to tell a computer how to do something, like give it a set of instructions and say, hey, do this, i.e. programming, well, computers can only run binary code. And that's kind of a problem because humans, like I said, are really bad at understanding binary. And this just is a really hard problem because a human can really easily program, but it's sometimes very hard to put that into a scenario of just ones and zeros. So what the solution is we have something called compiling. And compiling is basically the process of taking code that humans can understand and changing it into something that a computer can understand. Taking your C++ script and turning it into actual binary code that your computer can run. So yeah, that is actually what compiling is. And this is honestly where we get into this series. And by the way, I'm going to be using the words machine code and assembly language, or basically just programming done in binary. Wait a minute, I think I might be blanking on that. I might be wrong. Let me know in the comments if I'm wrong. But machine code is just, I know for a fact that is coding in binary. Not sure about assembly language though. Again, if someone would let me know, that would be awesome. Anyway. So now let's talk about what we're going to be doing in this series. Because now that we kind of understand that we have this problem in terms of compiling between computers and humans, the thing is that we don't just have to, when we code in, to put it one way, human speak. The fact that we're taking code and we're making it into something else makes it so that it's sometimes very useful for you to actually just have your computer, for instance, simplify things for you by doing some simple things. And as a matter of fact, a lot of these quote-unquote simple things are major programming things that are really easy to do in programming languages. And the thing is that it's a lot harder to do these functions if you're just programming in machine code. So that gets us into this. So what I'm going to be doing in this series is, first of all, I'm going to be explaining everything that the computer can do. And then from there, I'm going to be starting and I'm going to be going up and explaining how the computer does all these quote-unquote high-level functions, like loops and functions and object-oriented programming that are pretty easy to do in stuff like a programming language that you might use, like C++ or Python or, I don't know, C#, Java, Perl, something like that, Ruby. And the thing is that you will not learn these things when you're actually learning how to program in these languages. So yeah, what I'm going to do is I'm going to basically use the computer that I built in my Explaining How Computers Function series, and I'm going to kind of implement these advanced functions into that computer where it's possible, but there are a few things that I can't do in that. And that brings me up to the other thing I want to talk about here. And that is that at this moment, I have not actually finished debugging my computer. But what I wanted to do is I wanted to get this on the road because it's what a lot of my viewers want to see. And honestly, it's something else I enjoy. And while my general work ethic is very focused on making sure you finish something before you start another thing, I decided that what I'm going to do here is I'm going to do the explanation videos, and I'm going to do something similar to my computer function series, where I'm going to make separate videos for implementing it into my Minecraft computer and actually explaining how it works. So what I'm going to be starting up this series, and as soon as I finish debugging that computer, I'm going to start making videos that will go along with this series in order to show something like this in function. So yeah, so it's up to you to decide whether you want to watch with this, but with that, I hope you guys have enjoyed, and I'll see you guys next time.